Stoichiometry notes, example 6, second year chemistry, Chem II. Aluminum chloride reacts with magnesium sulfate to produce. Please write a balanced chemical equation for this reaction. Welcome back. Here's the equation. Make sure you've balanced it. Here's the equation balanced. Okay, we're going to start with how many grams of aluminum chloride will react with excess magnesium sulfate if 85.1 liters of aluminum sulfate is produced. We have a density. All right, as we look at this problem, we're going to figure out what our starting point is. Remember that we must start something with a mass, a volume, or a mole, and we must have the limiting reactant. So it tells me 85.1 liters, that's a volume, won't start with the density, so the only option I have is to start with this, 85.1 liters. So we're going to start with 85.1 liters of aluminum sulfate. Okay, and I got to get to grams of aluminum chloride. That's where I'm trying to go. So I got to get rid of liters, okay? To get rid of liters, I'm going to have to use density. Remember that density is our pathway between mass and volume. I can't use my balanced equation or the periodic table until I get to grams. So I must get to grams from volume using density as my pathway before I can do that. So I know that for every 1 liter of anything, there's 1,000 milliliters. So 1 liter of aluminum sulfate equals 1,000 milliliters of aluminum sulfate. But my density is 2.6 grams per centimeter cubed. Remember what that looks like. That is really saying the same thing as 2.67 grams over 1 centimeters cubed. Remember that this forward slash says that we're putting it underneath with a 1. Okay, so I got to get to centimeters cubed, but I know that for every 1 milliliters of something, there's a centimeter cubed of it. So 1 milliliter of aluminum sulfate equals a centimeter cubed of aluminum sulfate. Now I can use my density ratio to flip from volume into mass, and I can write this way, or I could write it the other way. I could flip it, meaning 1 centimeters cubed equals 2.67 grams. So we need to see which way we need that. We need it the right side way up. So we put centimeters cubed here so they cancel, and grams of aluminum sulfate goes on top. Now I can use the periodic table to get from grams to moles. We know there are 342.17 grams of aluminum sulfate. Remember, that's 2 aluminums, 3 sulfurs, and 12 oxygens for every 1 mole. Remember, the periodic table number is always grams per 1 mole. And then we can mole shuffle. We're going from 1 mole of aluminum sulfate from our balanced equation for every 2 moles of aluminum chloride from our balanced equation. And then the final thing we can do here is to go from moles to grams, because remember, we're trying to get to grams. Currently, we would have been in moles, but we know for every 1 mole of aluminum chloride, periodic table number is 133.33 grams of aluminum chloride. When we multiply the top numbers across the top, hit equals, divide by 342.17, we get this number, 177,000, with only 3 sig figs, or in other words, round it to 3 sig figs. So we start it with volume. We convert it using volume conversions. We use the density to get us from volume into mass, and then it's an ordinary stoichiometry problem.